Since 1992, the LIFE programme of the European Commission has co-financed more than 3,800 environmental projects in its 20 years of implementation. With more than €2 billion contributed, it has enabled the development and implementation of environmental policy and legislation in Europe. The LIFE programme helps to integrate environmental aspects within the rest of the policies and, in a broader sense, contributes to sustainable development. Water jet cutting technology is widespread and applies to a wide range of materials of different hardnesses and thicknesses, always seeking the precision of the cut by means of the previously digitized design of the pieces. Different materials can be cut: metals, steel, titanium, aluminium, copper, brass, wood, cork, composite materials, food, and other materials. Once the piece to be cut is digitized, the machine moves its cutting head to reproduce the shape designed on the computer. A very fine jet of water at high pressure cuts the material as the cutting head moves over it. The main factors affecting the efficiency of water jet technology are the pressure of the jet and the speed of the cut. To cut harder and thicker materials, tiny, very hard sand particles are mixed into the water jet. It is these abrasive sands that give the name abrasive water jet cutting technology. But it is at this point that the technology becomes environmentally more expensive and less sustainable. Abrasive sands are a type of sand that are mostly brought from Asia and have to be transported over long distances. These abrasive materials with use lose their properties over time and generate huge amounts of waste that must be managed by the company. The figures speak for themselves. A company of 10 employees specializing in water jet cutting technology needs to buy more than 30 metric tons of abrasive sands per month, which must be transported from more than 10,000 kilometers away, and which generates more than twice that amount of waste. This means huge expense for companies and causes serious environmental problems. ICE JET is a European Commission LIFE project carried out between Spain and Slovenia. 4 partners are involved in the project: Tecnalia as the coordinator of the project and the foremost private research and development organization in Spain, the Faculty of Mechanical Engineering of the University of Ljubljana as a leading organization in jet cutting research, Yamkut as the company specializing in water jet cutting processes, and Ad Hoc Desarrollo Sostenible as the expert company in the management of LIFE projects. ICE JET is a demonstration project which has developed a substitute technology using ice particles instead of abrasive sands. It aims to solve the 3 major environmental problems created by water jet cutting technology: the large consumption of abrasive materials, transport from distant countries, and the enormous amount of waste generated. This all causes significant expense for the companies. Ice particles with the same hardness solve the 3 problems mentioned. The ice particles melt into the water after the materials have been cut, and the water is reused in the creation of the jet. 2 prototypes were developed to demonstrate that the substitution of abrasive sands by ice particles is technically and economically feasible. One of the project prototypes has been developed in the laboratory in Technalia. This prototype develops two technologies: the production of the ice particles themselves and the incorporation of the ice particles into the water jet during the cutting process. In an insulated chamber at a very low temperature, ice particles are produced by spraying previously cooled water into a liquid nitrogen atmosphere. Thus, the ice particles produced acquire optimum hardness and size. A process has been standardized in which the amount and quality of ice particles can replace the currently used abrasive sands during the cutting process. The second part of the prototype consists of adding the ice particles to the water jet cutting process. Tests have been carried out where one can see how the ice particles become part of the water jet. However, the standardization of the cutting process itself will require further adjustments to improve efficiency before its industrialization. In the laboratory of the University of Ljubljana, the second prototype of the project has been developed. This prototype focuses on the creation of the ice particles inside the water jet during the cutting process. For this, the University of Ljubljana has worked on water jet morphology and its behavior at different pressures and temperatures. All the parameters dealing with the process have been carefully monitored. The morphology and temperature of the jet have been the two critical aspects in the development of Prototype 2. A detailed analysis of these parameters and water jet behavior has been carefully carried out. A thermographic study has been carried out on both the water jet and the cutting head. Creating a very cool atmosphere with liquid nitrogen has enabled researchers to establish how the ice jet performs during the cutting process at very low temperature. The study shows that the ice crystals are produced within the water column when working at very low temperatures. The first cutting tests carried out with Prototype 2 on aluminium demonstrate the increased efficiency of the cutting process, both in terms of power and of speed. Combining the best results of each of the prototypes, final tests were carried out at the University of Ljubljana. Different materials were used to demonstrate the improvement of the cutting efficiency of the ice jet technology. The improvement in the efficiency of the water jet without abrasive material will allow a broader range of materials, thicknesses and hardnesses to be cut without abrasive particles, thereby avoiding environmental impact. Results from life cycle analyses carried out in water jet, ice jet and abrasive water jet technologies have shown that ice jet technology is a far more sustainable alternative than that of the abrasive water jet. A solution may be in sight to the undesirable effects of the higher temperature caused by friction on heat-sensitive materials like certain plastics or food. Proof of this is that the burrs produced after the cutting process are smaller and color changes or other undesirable effects can be prevented in the areas in contact with the water jet. These results reduce the need for final treatments. The lack of abrasive debris is another important advantage because the ice particles melt into the water after the material is cut. Aware of the impact of this technology on water consumption, the pilot plant has developed a water recycling system where the water can be reused once traces of cut materials have been removed. Companies using ice jet technology will benefit from improved competitiveness as a result of the reduction of the costs related to the purchase and transport of abrasive materials and waste management. Micro-cutting processes in which the energy needed to maintain cold conditions can be minimized will benefit from ice jet technology. Surface treatments that seek precise patterns of roughness without cutting the pieces completely will be a niche market of ice jet. There can be no doubt that ICE JET offers a promising future for a cutting system that ensures accuracy and complete absence of traces of foreign materials. Such is the case with small pieces used in surgery, prosthesis, dental implants, ophthalmic lenses, or small hearing aids. Heat-sensitive materials will benefit from the technology. Changes in their characteristics and non-desirable effects will be avoided. ICE JET will also make use of the properties of ice for the cold cauterizing of tissues. The main beneficiary of the use of ICE JET technology will be the environment. Europe moves ahead by breaking the link between the use of natural resources and the environmental impact of economic growth. Companies using ICE JET will be able to avoid the impact of the consumption of non-renewable raw materials, their transport, the waste generated, and the water consumed. Europe will be able to avail itself of an environmentally sustainable technology to replace current abrasive water jet cutting technology. ICE JET is a European LIFE project co-financed by the European Commission. The project has been developed in Spain and in Slovenia between 2010 and 2012. 4 partners have taken part: Tecnalia Research and Innovation, Spain; the University of Ljubljana, Slovenia; IAMCUT, Spain; and Ad Hoc Desarrollo Sostenible, Spain, with the external assistance of Prisma Calidad y Medio Ambiente, Spain.